Hi everyone, thank you for joining me. Today we're going to talk about CSP, where it is broken, what can you do to fix it, or just demystify some of the aspects of CSP. So once again, thank you for joining me for this talk. Okay, my name is Amir Shaked. I lead the engineering and research at Perimeter X. Perimeter X, we're a cybersecurity company doing multiple AppSec products. And I'm a lifelong hacker, and I love building things with good people and seeing them used to help people in any aspect, especially protecting from bad actors. Okay, so let's begin. We'll start with a story. The story of I wanted to enable CSP on my own website. I went on and I read and understood the meaning of all the directives and all the different options and configurations exist. The documentation was pretty straightforward. I added the CSP header with the report only option to see all the potential traffic coming out of my website. I analyzed it. About a day later, I marked all the resources that I really think are related to our website and configured the CSP properly, rolled out block mode, and had zero issues with my infra. Everything kept on working properly. So that's my story. And I think no one ever said such a story because it doesn't work. It never happened in such a way for multiple reasons, and we're gonna see examples of some of those reasons today. A different story that happened later that year, this one is a real story, unfortunately, came from a customer of ours. They got a call from the credit card company and telling them that a lot of credit cards were stolen via their website. Working with them, trying to analyze the details. They brought in a security consultant. They found a third-party vendor that was used and was responsible. The third-party script was breached. Their source code was breached. And that snippet started sending additional information collected from the page to an external domain, say malicious.com, but any external domain. And that's how the credit card information was stolen from the website. And one of the things that was brought up was a question of how can it be? Because CSP was supposed to do exactly that, protect the client side in terms of what types of communications are allowed and where can the data be pushed over to. And the sad story is that the CSP was there, but it wasn't there because of a lot of gaps that can happen while you're configuring it. Either it's missing some key directives or setting a connect source only from where you can pull script, but the attacker just bypassed that with some image tags and adding the information as a request parameters. And we're going to touch on some key examples later on in this talk. Okay. So what is CSP? CSP is first of all, it's short for Content Security Policy. It's an added layer primarily focused at trying to protect from different types of attacks on the client side, mostly cross-site scripting or data injections. And those attacks are mostly used for different kinds of data theft or phishing, defacement potentially, though that's less common. It's mostly, those excesses are mostly for data theft and either directly or indirectly via phishing forms trying to extract extra information, additional information from the user. The standard itself, originally named content restrictions, actually, that was proposed back in 2004 by Robert Hansen. and it was first implemented in Firefox 4, actually. Later on, the first W3C draft became public in 2012, with the latest version 2, which is the most common one used today in practice. We had the final version in 2016. And version 3, which adds a lot of additional layers, but again, sadly not enough. That's still in draft mode and still open for comments. So how does it work? What's the big promise and the idea behind CSP? Essentially, there are two types of headers. It's an HTTP header, where there are two of those. One is for report only. They both have the same policy, but they behave differently. There is the report only policy, whereas the browser will behave as if it is going to do the policy enforcement, but it will only send information on what would have happened should the policy have been enforced. And the other is active blocking, basically enforcing the policy and having the option to report what was blocked. So let's look at this example. We have 3 directives, the default source and script source and report URI. What we basically have here is any default source self says anything from the website's domain can be loaded. JavaScript code can be loaded either from the domain website or from cdnjs.net. And if there is any violation, that's going to be reported to our domain/CSP logging. Now, if you look at the example, we have an image loaded from a local website and a script loaded from the CDN whitelisted domain. That's going to be valid and going to work. And if for some reason we have an additional request coming from our website, that will not work. And you can see it will not work because the domain is a bit differently. It's .com and not .net. Okay. So it looks like a great story of how a policy standard can help us protect client side. But the problem with specifications, like any specification, is the gaps that it have. And here is where the story starts, going down the rabbit hole. First, it's not fully defined. Things like what a report holds, when to report, leading to inconsistency when you're trying to actually analyze information, those metrics or logs being reported by the browsers. The implementation itself may be lacking. Just search CSP in the CVE database and there are always items being found. And it's very usage dependent because it's policy based and that can be abused. And we're going to cover examples on all of these gaps in the specification. So let's start with numbers. Is it actually being used? You know, it looks like a great technology, a security technology, but is it actually being used out there by web developers or DevSecOps administrating websites? This data is based on the HTTP archive scans from the past few years. It's an amazing database. It's my first go-to when trying to do analysis on how different web technologies are being used. While it can always have gaps, it's just an amazing data source. Each month they scan around 4 million websites and store all the information in the HTTP archive database. Anybody can access and use it for research. So what do we see here? What we have here is the use of actual security headers over time in the past few years, and that you can see it relative to the amount of scanned domains, so it's relative information. And what we see is actually very interesting. We see that, first of all, the CSP adoption grows while slowly, but it is growing at about 10% of the sites today. And if we will look at the actual items, we'll see that the first, the top one is mostly, that's all the security headers, by the way, as you can see, not just CSP. So we see a growing usage of 2 headers that are actually deprecated and were replaced by different directives in CSP. and we do see an increase in overall the security options in HTTP. But they're mostly around making sure the traffic is secured by TLS. That's what we can see here. So it looks like a positive trend. We see more and more websites using these security technologies. But if we actually look at those 700,000 websites using CSP and trying to understand what they're actually using, we'll see that they're basically these directives are the most common ones, and they're basically just replacing the obsolete ones with the new version of those. So it's not a real adoption of the more complicated and interesting directives. It's mostly just the TLS. What do we have here? Brief explanation. So the top one, frame ancestors, that directive states if our website is allowed to be embedded within a page, should the browser allow our website to be embedded within a page. That's the most common one. The next two, the upgrade insecure, moves all the traffic to HTTPS, and block mixed content states that no traffic should be without HTTPS. So do not allow both secure and insecure connections for within the page, just in case somebody made a mistake in the programming. All the fetch directives, default source, script source, etc., those are the ones actually controlling the domains that can be communicated from the website. So these are the interesting ones we want to focus on, and you can see that the adoption here is still pretty low compared to the amount of websites out there. So it looks like a positive trend, but there is still a gap here. You want to be mindful when you're talking about a policy. Some of the examples I saw when I started to dive into all those thousands of actual users in the wild, we see cases where a very insecure usage, like default source, which allows any unsafe eval or unsafe inline code, essentially allowing anything to be run on the page, protecting nothing, versus a very restrictive mode, like the script source with the nonce, stating that any inline code should match one of these signatures. So somebody can't even manipulate your own inline code unless they actually control the server, obviously, and can change everything. But outside the website, they can't control it. We saw a lot of examples of just poor usage. When I was looking at the directives, I saw over 700 of those, when there should be only about 30. I gave some examples here. The last one, I would say the funniest for me. It's been around for a while, go for it. I really have no idea what they were trying to accomplish with that policy, but a lot of mistakes from different kinds when actually trying to implement CSP, spelling errors, replacing the header key with the header content, and the issue is that whenever the policy is invalid, it's just not doing anything, and there is also no reporting. So you can really have no idea that nothing is actually working. So I really invite everybody who's trying to use it to use the CSP evaluator by Google. It's an amazing one that shows it's the best evaluator I've seen to date to make sure the policy is actually accurate. Okay. So let's talk about actually reading the reports. This is an interesting case. When you actually have an installation in place with the reporting on different violations and you're trying to understand what you're seeing, you see that data isn't normalized. It really is full of stuff that's not relevant. Anything that an extension on the browser that adds code to the page will actually create violations that you have nothing to do with. Ads can create that noise. Web proxies that load the website can create it. Bots as well. And the issue is that all that nonsense of information is really creating a lot of problems in trying to analyze if there is a problem with the policy that you created. Do your users experience any kind of problems or not? Let's take extensions, for example. This is an interesting case. By design, an extension within a Chrome browser can bypass the website's CSP policy and can ignore it completely. So it's not protecting from stuff that can come from within the machine itself, like an extension installed on the browser. But if the extension is doing something within the page in a certain way, you will still get the violation report from that extension, and you have nothing to do with it because they will still work. The last one here has some, the GitHub here has some really interesting examples of trying to explain, and a lot of unexplained cases as well, different reports that risk security analysts have seen over time. And then we have the browser misalignments. The actual, like we said, the actual data it's not defined within the spec when and how the information should be sent. And you can see a few examples here which are actually very interesting. Let's start with Chrome. In Chrome, if a block was actually, a resource was actually blocked, then you will get the report once and only once for that first block, even if the resource is being called again and again and again. On Firefox, for example, you will get the report for every time the resource is trying to be called. So that's one big difference on its own. And then Safari, at least in the version that we analyzed at the time, would only report the block URI, for example, and it would truncate that to the top level domain. It won't give you the full URI. So these kind of misalignments create a lot of noise, but also create some guidelines or tricks that you can use to get better value out of the reports that you're getting. And last but not least, I haven't seen a lot of cases of this, but log spamming, where the client side, by design, cannot be verified and the reporting can be abused, especially if you have some machine learning model trying to learn what domains should be whitelisted by volume, for example. So either it's creating a DOS on your SOC group or just trying to do adversarial machine learning. The fact that there is no validation on the reports can be an attempt to abuse the concept and put domains into the whitelist. Okay. So we talked a lot about the first item in the agenda. Let's talk briefly about the second items. Just looking at the CVEs over time, we see there are implementation gaps, and I don't blame the browser developers. It's a complicated policy, complicated standard, and it's not easy to create a safe system to fully implement the policy, but you do see gaps over time. Overall and specific in the specific browsers over time, gaps in the implementation are found. I want to give an example of one such CVE that we found and published last year. It's pretty straightforward to explain it. So using the following directive, say object source should be none, child source none, and script source only from yourself. The following code should be blocked, and it is blocked when you're just trying to create an element and add a URL coming from an external domain. But if we do a little trick, creating the element as an iframe with the JavaScript source in it, that will work. Now, this was patched already and it was resolved, but it's an example of how attackers can really try to find the slightest gaps in the implementation to bypass the way the model actually works within browsers. So here is an example of such a case, obviously already mitigated by Chrome. And the last one is the story I like best because it really takes all the concept of having a policy and break it apart and show how it can go completely wrong. And the idea here came from the research concept here was straightforward. So looking at all the websites and all the domains that are whitelisted and how they're actually using CSP, the question came to mind was, okay, let's look at the most common allowed targets for this traffic from the website. What are those actually being used by websites? And we can see that if we look from March 2020 to June 2021, the most common one was, and still is, just in increasing numbers, Google Analytics. And this is just the top level domains. You can see here the example of all kinds of subdomains. It's in June 2021 as well, just lower numbers. But just taking the top one without even following domains, Google Analytics is the most common allowed domain in CSP policies when they're actually trying to limit with the fetch directive and not just have the high-level TLS protections. And if this was live, I would ask what would you do with it? We'll jump to the answer. And the answer is, let's try to abuse it. If they're whitelisting Google Analytics, can we use it to extract information? Obviously, the answer is yes, that's pretty simple. There are no built-in protections around that. So we just add a piece of code to the, let's say we breached a third-party script, breached a supply chain in some way. And it's important to remember, breaching supply chain is a very common technique, was and still is. Even just a few weeks ago, there was it was an actual breach, but it was a risk published on Cloudflare's CDN GS, where a potential malicious actor, could change code being served by the CDN. So that's an open risk, and it can happen from anywhere. It can happen at the CDN level, and it can happen on a small company without the proper security measures being breached, but their sensor is used in our application, because that's how you build modern applications today. So let's say you try to protect yourself with XSS, you put the CSP and control the domains. Somebody can still abuse the safe list by adding a few lines of code, assuming you're whitelisting Google Analytics, most do. And just send the beacon on the data collected on the page. The code is pretty simple and straightforward. And then we go into the Google Analytics page. We have the information, extract the report, base64, and there we have it, username and password being collected. And all the protections that we try to build collapse under the fact that we just whitelisted Google Analytics. So trying to protect that, the next question that comes to mind is, let's put some query parameter protection. Wouldn't it be nice if we could just protect and say a specific account, TAD, let's limit it to specific values, and then for actually pretty obvious reasons, performance mostly, query strings, this is a quote from the spec, you can't protect query string parameters. It's not evaluated within the expression. Only the top level domain is part of the policy, nothing beyond that. So that won't work. And the interesting thing is, the flow was, so this is a theory. Somebody might be able to do it because that's the most common one. We published the article about the method as a theoretical idea, and then just a few days later, there were reports by different security vendors stating that they actually found this method being used in the wild by skimmers, digital skimmers, abusing the concept of Google Analytics by CSP. So the flow here was interesting. We looked at what is the most common, how can we abuse it. We looked at it as a story, and then the fact is that this is actually being used in the wild by attackers, means that it's a very real risk that attackers have found and are already abusing. And there is no mitigation around this. This is important. And it's not just unique to Google Analytics as well. And here is where it went wrong, if you want to look at it. And managing a policy, it just doesn't hold in today's modern web apps. And it's not just Google Analytics, they're not unique. if you look at the concept of trying to whitelist domains, when you're constantly adding third parties, first party all the time, and you're trying to manage different SecOps teams of who can add code and where, it becomes impossible to limit the domains that are actually being used. But even when you try to limit them, the most common ones that are actually being used, as you've seen from the data itself, from what SecOps teams are actually doing, all of those are websites that by potential can be used the same way that Google Analytics was used. Anything from either if it's free accounts where you can create on YouTube or Twitter on all of those, or even if it's paid accounts on some vendor, it would still be very cheap to create an account and then use the domain to send information. Now, in order to protect here, we need help from both ends. These services, they can help if they will define I would say, the destination ID as part of the subdomain and not just part of the query parameter, and won't allow it also as part of the post data. Or even if the post data is being sent, they will validate that the subdomain matches. Think of it. If all that they do is Google Analytics and other vendors, big vendors like that, will add the option to use a subdomain, then the CSP would work and it would be a hit. But most of them don't allow that. So that's one gap. And the other is, from our side, limiting those destinations and also removing these resources where if we don't have to have them in specific parts of the site. So even if we do use Google Analytics, maybe we can remove it from sensitive pages where there is sensitive information that somebody can try and steal from us and for malicious intent. So let's talk about what we can do to make the best of it. One thing I haven't mentioned, going back to the first item, is how we can differentiate if a report is coming from one user or the other. And most common practice here is to create some either random value in one way or another on the report URL as a request param. So you add an identifier, and then when the report comes back from the browser, if there was a violation, you can use those request params in order to understand which user or how many users were actually affected with that report. Say you have a session ID being set by your JavaScript code, the server can take that into the report and bring it back as part of the header. So we'll be able to differentiate between different users and understand how many users you're seeing versus how many IPs you're seeing with reports. Second is to filter the reports. The best practice that I recommend here is to focus on the most common browsers you see on your website, whether it's Chrome, Safari, or whatever. And just focus on those. If you have a problem with your policy, it will pop up on the common ones. It's really no point on trying to focus on all the esoteric cases. There is the option to A/B test the policy, which is actually pretty cool. You can take a subset of the traffic, use a report-only policy on that, do it even in a very strict, limit everything, and then you can play with which domains you're allowing and disabling to make sure that the policy is up to date and accurate, and that you're not leaving domains that are invalid or irrelevant. One example I've seen is on websites that whitelist domains just because they did a POC with some startup, then they dropped it, and then later on the startup was closed. They still whitelist the domain. Somebody can just buy the domain and use that as a drop point. So also something you want to make sure that your list is up to date with relevant domains and not something you added before. And that's because there is no report on what is actually being used. It's only reports on violation. One of, again, a gap in how a policy can be used. But the nice thing here is you can use that to your advantage and A/B test the policy and make sure it's always up to date and limited. I would also recommend adding more layers of security, such as nonces and hashes on only inline code. If you can do it, it will protect you as well. And last thing, like I said, being context aware. Different policies for different sections of the website, also very important in order to better protect and limit the built-in gaps that there is within CSP. So I'm saying a lot about gaps here in the concept, but it still is a good concept. It's not like you have an alternative to CSP that is fully proof and bulletproof. So I would still recommend to use it, but be aware of the issues. And definitely, if you have ideas as security researchers, especially, to come up to CSP3 with comments. I'm sure there are ways we can improve the standard. That's it. Thanks for listening. I'm open to Q&A. I'm happy to answer any questions that you have.